but just a general shape, so as long as you know the basic shape of the log function. So the very first picture does not have any specific base or anything like that, but I thought this was a decent picture. This is a general shape of a log function. So they have f of x equals log base b of x. This is the same as y equals the log base b of x, if you like that better. And just to remember, the little subscript is not allowed to be negative, and it's not allowed to be equal to 1. So it just says there that the subscript, this will work for any time that subscript is bigger than 1. If it was, now the subscript can be a half or it could be a fourth. I'm not going to have you guys graph anything like that in here. That'll be for pre-calc, but we're just going to graph if the b value is bigger than 1. So this would be your general shape. Okay, now the other thing, I'm going to show you this real quick with an actual number so I can hopefully make it make sense. But anytime you have a log base b of x, it will always go, no shifting or anything, it will go through the point 1, 0, and then it will go through the point whatever the base is 1. So I'm going to explain that to you guys here in 1 second. The other thing I'm going to draw out real quick here, just in general, I'm going to give you like a domain and range for these. And this is a little bit different than any graph that we've done so far. So domain and range, just in general, for a log function that has not been shifted in any way. Can anybody tell me, just looking at the graph, what you think the domain would be? For my x value. This is very tricky. Yes, okay, so the graph, this is like an exponential, but it's actually the inverse of an exponential. It is turned around though, or flipped over the line y equals x. So the asymptote here, this is going to approach, if you guys remember graphing those, is going to approach a vertical line instead of a horizontal line. So it does have an asymptote here. It would be x equals 0, and that's going to affect the domain. So the domain here, you're not actually going to touch 0. We're going to explain this in a second with some actual numbers, but then it points to the right forever. All right, so that's your domain. X equals 0 would be your asymptote. You get really close to that x-axis, or sorry, y-axis, but you won't touch it, won't go over it. Now the range, this guy's going to go down forever. This goes really gradually, but it goes up forever, so the range is actually negative infinity to infinity here. Okay, now here's a more concrete example with labeled axis, all right? So this is, and if you prefer, this is y equals the log base 5 of x, just so I can show you guys why these points always work. So remember I told you it would go through 1, 0, so it does. And at whatever the base is, the base here is 5, it'll go through the point, the base, and 1. So let me explain to you why that is. Okay, now, in my little, let me make like a teeny tiny little table. So I have the point 1, 0, and I have the point 5, 1. Okay, now on this graph, I'm just going to plug in what the x value is right here real quick. So I would have y equals log base 5. If I plug in 1, it would look like that. Y equals log base 5 of 1. If we do what we've been doing, where we converted this to an exponential, which I'm going to do real quick, I'm going to push this over here. So the base of the log becomes the base of your exponent. So that would say 5 to the y power equals 1. Okay, anything to this power is 1. 0. So that's why in that scenario, and then you see that's my y coordinate at that point. Okay, if I repeat that process, if I do log base 5 of, and I plug in 5, forgive me, I should have written the y first, and I totally didn't. But if I plug in 5 for our equation, I'm just going to convert this to an exponential real quick. I'd have 5 equals 5 to the y. So in that case, y would have to be 1. Now, I'm not asking you to do this in any way, shape, or form, but these have a lot of just like really weird decimal points, but those are nice solid points you can always get. If I was actually had to graph more points on here, I would try to think of numbers I could plug in that would have a nice log. So like, just let me give you an example. So I would maybe plug in 25 for x. So if I did the log base 5 of 25. And that was equal to my y. If I swing that, I'd have 25, 5 to the y. So in that case, y would have to be 2 to make that true. So another point, which it would be way off the window of the graph that I have here, but I would pick powers of 5. Like the next point I would maybe do that would be a nice value. I could do 125, and then that would be all the way over to the right, but it would only be up to 3. So it goes up very, very gradually. But if you guys can remember, any of these graphs, 1, 0, and then the base 1, those are going to be the 2 points I'm going to look for. It would change depending on what the base is for the graph. So that's what we're going to look at when we do our shifting here in a second. I am going to have you guys, there's another way you can graph these, and that is actually to graph the inverse. So I'm going to have you guys look at that as a method for graphing here too. Okay, so it says logarithmic functions and exponential functions are inverses of each other, like we were switching back between the different formats. Now, one way to graph a log function is to find the inverse of the log. So switch x and y, solve for y, graph the inverse, and then we could reflect it. So I'm going to go through how I would graph log base 3 of x. So if I found the inverse, here's what I would do. I would switch x and y. So I'd have x equals log base 3 of y. And I would solve that for y. It's literally just one step. You're going to swing this 3 over to the other side. Base of the log is going to get rid of the log, push that exponent up in the air. This would say to you 3 to the x equals y. That is the inverse of the log base 3 of x. Now, I just happened to already write that on the paper for you, but I wanted to show you the work behind it. So I'm just finding the inverse. These two are inverses of each other. Log base 3 of x and y equals just 3 to the x. Now you guys, hopefully you remember graphing exponentials a couple weeks ago here. If I do 3 to the x, if I plug in negative 2, that would be 1 over 3 squared, which would be 1/9, or you could write it as a decimal. If I did 3 to the negative 1, that'd be 1 over 3. Anything to the 0 power is 1. 3 to the first would just be 3. And 3 squared would be 9. And we could continue to get more points, but that would maybe give us a decent shape of our graph. So I'm going to come over here. I'm going to graph these real quick. So if it's not a nice number, just kind of estimate. So 1/9 at negative 2, I'm just going to come a little bit above the x-axis. 1/3, just a little bit more above it. 0, 1, 1, 3, and then 2, 9. Then remember, this will get really close to the x-axis, but never touch it, never go over it. So that would be y equals 3 to the x. Now it's inverse. If you guys remember when we did the functions, if you have an inverse, you can literally just trade the table places. So the x-coordinate becomes the y-coordinate becomes the x-coordinate. So in this case, if we plugged in 1/9 for x, log base 3 of 1/9, we would get negative 2. If we did log base 3 of 1/3, you would get negative 1. These are all true statements. If I plugged in log base 3 of 1, we'd get 0. Log base 3 of 1 would be 3. And log base 3 of 2, or log base 3 of 9, would be 2. Now, this, whenever you have inverses, they're a reflection over the line y equals x, which is why I have that little dotted line in the graph there. That is the line y equals x, just to show you the reflection. If I graph this perfectly, we could fold them in half on that diagonal line and the two graphs would match up. The actual log function is what I'm going to graph right now. Now, this is weird, so try to maybe like kind of estimate, go over to the right 1/9 and then down to negative 2. And then over to the right like 1/3 and down to negative 1. Now here's the point. Remember I told you these will always have the point 1, 0. So there it is. And then I have the point 3, 1. That's the base and 1. So these are the 2 points that I'd be looking for if you're shifting something. I'll show you how to do that on the back. If it asks you to do it like this, make sure you got 5 points. And then I've got 9 all the way down here and then up 2. Now this guy gets really close to the y-axis, but doesn't touch it, doesn't go over it. So the log is the one I did on my graph on purple, and then the exponential is the one that I did on red. They're inverses of each other, so this is one way you can do this. Now, if you guys remember, from the exponential, that goes left and right forever, so negative infinity to infinity. The exponential, you don't start touching that graph till you hop over the x-axis, so that would be 0 to infinity. In the case of the exponential, sorry, I should have spaced this out better. The asymptote is going to be horizontal. It's going to underline that kind of that J shape, so it would be y equals 0, which is actually the x-axis. It'll be a horizontal asymptote for any exponential function. For any log function, and if you guys remember this, if you know the domain of the original, you know the range of the inverse. If you know the range of the original, you know the domain of the inverse. And these should be what we were just saying. The log, 0 to infinity. I don't start touching any part of that log graph till I hop over the y-axis. And then the range, it does go very gradually, but it goes down forever, and it does go up forever, negative infinity to infinity. In the case of a log, the asymptote is always a vertical line because it's an inverse of your exponential. So it's going to be vertical, and it will be x equals 0. We don't have any shifting here. We'll shift on the back. Does anybody have any questions? Okay. Now, here I've got a general form for you. Okay, so just log base b of x, plain, had that on the front, right? Always has the point 1, 0, and b1. We're going to shift those 2 points, and the shifting works just like shifting works for every other graph that we've been talking about. So inside, when you're going to take the log with the x, so if it's in there, it says x minus h. This is going to go left or right, and it's going to be the opposite way you think. That affects the x value. And then outside that set of parentheses, I've got this plus k. That's going to shift your graph up or down, and then exactly the way you think. So like if it's plus 3, we're going up 3. If it's minus 10, we're going down 10. Okay, now I'm going to do base 5, and we're going to see if we can put these in the same graph as the original. So I've got just log base 5 of x graphed on both of these, and we're going to do these 2 shifts and see if this makes sense to you guys. Okay, so if I give you log base 5, and I have x plus 2, and then outside of that minus 4, could you describe to me like how that would move compared to just log base 5 of x? Okay, so we're going to go left 2, down 4. Okay, so remember my original points were 1, 0, and in this case, 5, 1. That's not shifted. Okay, here's what you're going to do. We're just going to manipulate these points. So, to the x, I'm going to subtract 2, and to the y, I'm going to subtract 4. Those are the 2 things. Left 2 would be minus 2, and then down 4 would be minus 4. So whatever affects the x, do that to the x coordinate. Whatever affects the y, do that to the y coordinate. So if I do that, that 1, 0, here, I'm going to try, I was trying to figure out where to write it. I'll just write it underneath. So 1 would go to negative 1. 0 would go to negative 4. So that would be your new point. And then 5, 1, if I subtract 2, that would be 3. And from the 1, if I subtract 4, that would be negative 3. So these are going to be my 2 new points for the graph. So just kind of, I know it doesn't have grid marks on here, so just do your best. So I'm going to go over 1, down 4. And I'm going to go to 3, negative 3. And I'm just going to try to draw that general shape. But before I draw anything, though, can you tell me what the asymptote should be for this shifted graph? What was it? what's the asymptote for this graph? -2. It's going to be the x. So the asymptote here is actually going to be x equals -2. So we're shifting the whole thing over. So the original graph not shifted is x equals 0. I'm scooching it 2 to the left. So that's going to move your asymptote 2 to the left. So if you guys want, I don't know if you wanted to draw this in here, but this would literally be like moving the x and y axis if you wanted to do it like that. It's kind of hard to do on this graph that I have here. But the x is going left forward, the y is going down forward. So this would be my new, it's the same thing, we're just shifting it left 2, down 4. That's what we're doing. Now, the range will stay the same. The range is still going to be -infinity to infinity. The domain here is what can change if you're working with a log function. So now, I don't start touching any part of the graph till I hop over that -2. Should just be your asymptote with a parenthesis because you're not actually touching that point, and then it does go to the right forever. Okay. That might be an easier way to do it. I don't know. How would you, if I gave you log base 5 x minus 3 plus 1, like how would that shift just log base 5 of x? Like if I did this one, how would you describe that transformation? If I do log base 5 x minus 3 plus 1, how would that shift it? Okay, so this goes right 3, up 1. Okay, if you guys want to just do the asymptotes, we could do it like that too. So right 3, I'm going to go like here. This would be like my new y-axis would be right 3. It's also your asymptote. I'm just going to write x equals 3. And my new x-axis, if I go up 1, would be like here. Okay, so if you have that, it's a little hard to do because I don't have grid marks on here, but you could graph the points like pretend that's your new set of axis. It'd be 1, 0, and then it would be 5, 1 here. So if I'm starting at 3, that would be 8, and then like up 1 here. I'll do it with the points too so you guys can see, but it would look something like that. If you prefer to shift the points, all right, 1, 0, and 5, 1. What I would do for each of these, for the x value, I'm going to add 3, and for the y value, I'm going to add 1. So that 1, 0 would turn into the point 4, 1. 5, 1 would turn into the point 8, 2. So if you want to use, you could just shift if you want to do the shifting with the axis, and then do the 1, 0, the base 1, or if you want to actually shift the points, kind of do what's going on in the question. It's up to you. The domain here then, again, it's going to start at your asymptote, which is 3, and it's going to go to the right forever. The range for all of these should be -infinity to infinity. Does anybody have a question? Okay. Now, these questions down at the bottom, they're shifted, but this is log base 4 of x. So we've been working with log base 5 of x. Log base 4 of x, those 2 points, 1, 0 for every one of these graphs, and then the subscript, which is 4 here now, and 1 to get that general shape. So if I take the log base 4 that would not be shifted. We don't have that on any of these screens to compare. But what I would do here, how's x minus 4 going to move just a plain log base 4 of x? Like if I do x minus 4, how would that shift the graph? Right. Okay. So this is going to go right 4. Okay. So if you want to just draw the asymptote in like that. There's 4. I'm not moving up or down. So it would still be the x-axis there. If you want to just pretend that's your new x and y axis and then plot these 2 points. So I would go over 1, up 0. It would be that point right there. And then from that new set of parentheses, this new like x and y axis, 4, 1, I'd go over 1, 2, 3, 4, up 1. And I could draw the general shape of the graph like that. They're all going to look similar to that. If you don't like that, if you're like, what the heck, what are you doing? I'm going to add 4 to the x-coordinate, the y-coordinate would not change. That will be the 2 points I just put on this graph. So it would be 5, 0, and it would be 8, 1. And if you look at my graph, those are the 2 points I have there. So if you want to do it like shift the x and y axis and go 1, 0, and then base 1, that's fine. Or if you want to figure out the shift and add that to those coordinates, whatever's easier for you. Domain here, we're going to go, let's see, 4 to infinity. And all the ranges are negative infinity to infinity. I'm just going to write that down for each one of these while I'm thinking about it. Okay, now asymptote should be a nice vertexal line. So I'm getting really close to this x equals 4, but we're not touching it. We're not going back over it. So it should be x equals 4. Okay, now this guy here, this is log base 4 of x minus 2, not in parentheses. So not in parentheses, this is going to shift your graph down 2 units. Okay, so it's not going to shift left or right. So the y-axis would remain the y-axis for this graph. The x-axis would scooch down 2 spots. So if you want to say, okay, I'm going to do base 4, so I'd have the point 1, 0, and 4, 1. You can just pretend this is your new x and y-axis. This would be the point 1, 0. This would be the point, let's see, 1, 2, 3, 4, 1. And then I'm just going to kind of make that general shape. If you're like, what the heck, Miss Grody, where did you get that? I'm taking the point 1, 0, and 4, 1. Now, if I'm just shifting it down, all I would do is subtract 2 from y. So the x-coordinate would stay the same. I'm going to subtract 2 from the y-coordinate. So 1, 0 would turn into 1, negative 2, and 4, 1 would turn into 4, negative 1. And if you guys look at my graph, those are the points that I have. Your domain is going to be based on the asymptote, which for this question is going to be 0 because it didn't shift left or right, so 0 to infinity. The asymptote would be x equals 0, which is actually the y-axis. There's no shifting left and right. Okay, I've got one more. I'll just do it real quick. This would go opposite of what you think, so it's going to go left 1 and up 3. So if it helps you in any way, I'm just going to draw a new asymptote here. Left 1, so the y-axis would scooch over 1 spot to the left. And then the x-axis, we're going up 3, so that would scooch up 3 units here. Okay, now, if I want to just use that as my new x and y-axis, and I can graph the point 1, 0, 4, 1 there, since we're doing log base 4, that would be here. And let's see. 1, 2, 3, 4, 1 should be here. And then just get that general shape. Try not to draw over your asymptote. What I'm doing in that case, to the x-coordinate, I'm going to subtract 1. And to the y-coordinate, I'm going to add 3. So these 2 points, this would become 0, 3. And then the 4, 1 would become 3, 4. And you guys, if you look at my graph, those are the 2 points I have. So whichever way you want to do it, if you want to just shift the x and y axis and draw those points, or if you want to add or subtract whatever your shifting is doing, the domain here should be negative 1 to infinity, and the asymptote would be a vertexal line at x equals negative 1. If you have a base 4. Now, like if we had a base 3, it'd be 1, 0, and 3, 1. Right, it would be, it's 1, 0, and then the base, I'm going to write that up on the board. It's 1, 0, and then whatever the subscript is, the base 1. So if I was working with log base 2, I'd have the point 1, 0, and 2, 1. If I was working with like log base 7, it would be 1, 0, and 7, 1. So just different shifts. So make sure you look at the equations that you got on the homework assignment as you go through there, that you use the right base. Is anybody having a question at the moment? Okay, I'm going to turn this off. Give me 1 second. I'm going to take attendance, but if you guys have a question or need help, I will be happy to help you with it.